I love Linux drivers. They're so good. I love when my internet shuts itself off for absolutely no reason, even though my network is up, and then no combination of rebooting drivers actually fixes it. It's freaking lovely. There is literally not a single working desktop operating system in existence that just consistently doesn't screw up. Um, oh, one row, quad, just chat thingy. Okay, this was what I was looking at, this function here. Better, right? And how does it look locally? If we go from like say -20 to status on neocarbs, yeah, figuring out ideal transforms mostly. Um, the issue is that with certain types of data, you need a meaningful interpretation of absolute improvement of score. But like your data could be percentile, it could be log distributed, it could be linear. So I'm looking for something here that we can use. It's locally pretty nice and linear. What transform? They use the quantile transform. It doesn't work with percentile data. And also it's a pain in the ass. It's like ridiculously overly complicated for what it is. Also, a lot of their stuff just doesn't work. So, yeah. I think that they like the thing is they mostly got the result that they did because they were the first ones to run a large scale hyperparameter sweep on ProcGen at all. Um, the algorithm was like okay, but it was more that the idea is very good and there's a lot that needed improving on it. Yeah. Well, because here, this is the type of thing that happens, right? Stupid researchers say that, like, oh, here's ProcGen, you're supposed to solve it with one set of hyperparameters. And then nobody bothers to, like, think that, wait a second, we're using PPO and, like, all these other algorithms that have time-dependent hyperparameters, like gamma and lambda, and these inherently are different per environment, and we're trying to force one set to solve all the environments, which is never going to work. So we're just going to sit here and like say, oh, it's hard, we can't solve it, instead of just tuning the damn hyperparameters, right? And so it's like ridiculous. Well, also ProcGen is like here's the other annoying thing. ProcGen, the environment is quite fast. ProcGen, the base model that everyone uses for it, is very slow. So basically, even if you give researchers nice things, they will find a way to ruin them. Yeah, this is pretty good. It's like close to linear locally. Yep, pixels as inputs. We have to learn from pixels. Oh, so you have compute, right? No, we're academia. We have $500,000 budget for compute. Oh, that's pretty good. So you're gonna buy like, a bunch of desktops or something, right? Oh no, we're gonna buy H100s and then we're going to run them at 10% utilization. And like it's just like lighting money on fire. Like they light performance on fire, they light money on fire. Drives me absolutely insane. How did I get Puffer off the ground? By buying some desktops and putting them in a garage. uh, it drives me insane, man. Isn't seeing like humans are? What's the point? What are we even doing? Exactly. If it isn't seeing like humans are. After all, us humans are so smart. We're the only species capable of building amazing things and then utilizing them at 1/10,000th efficiency. This is a pretty good transform. You gotta use them at 1/10,000th efficiency. Let's try this out. And then my favorite part is that then the scientists decide the science positions are more prestigious than the engineering positions. It's like, what are you guys doing? My favorite thing is now because I'm the scientist, I get to complain about this, and it's not even lame anymore. It's like lame when it's like the engineer complains, "Oh, why do scientists think they're so cool?" But now it's like I can actually say stuff, and it's like it works. It's the best part. And I can be like, "Hey, you scientist, write code that doesn't make my eyes bleed." This makes my eyes bleed. For reference, do not use this as your example. Diminish results. It's the opposite. You see, what happens is, so 18, 19, or was it here? 15 minus 14 equals 1, right? 20 minus 19 is also equal to 1. But going from 19 to 20 is you're solving the task, and going from 15 to 14 is a very small improvement. And the same exact thing happens with percentile data, right? Going from 0.9 to 0.999 is huge. Going from like 0.8 0.8 to 0.9 is not as huge. Well, that's because Claude is very stupid. Oh, did you see there was a hilarious thing in one of the Twitter chats where like somebody put in the U.S. tariffs plan, and Claude like could not fathom how it would even be possible, and was like predicting that the U.S. supply would be replaced by like the farm supply would be replaced by products from Asia, and the U.S. would crumble and whatever. And 24 hours later, yeah, 24 hours later, it's like, yeah, nope, that worked. It's ridiculous. Claude is not very smart. Okay, so this gives you transform scores, but I need to have like this. We normalize. Twitter is not good for you. It's very bad for you. R1, how do you talk about? Public code. Sends all the data straight to China. Unless you're running it locally. Of course, ChatGPT sends all the data to OpenAI. I don't know which one is worse. I mean, you data hogs. I have to set up our own private puffer cluster for running these things. Puffer cluster. Mm-hmm. Who do you trust more with your data? Sam Altman or Mao Zedong, who has secretly been alive all this time and is still leading China? They actually solved AGI and um, achieved immortality during the Cultural Revolution. And they did it with 5.5 million of compute. The heck? Barely. Yeah, about right. See, eventually, when the cutoff date goes far enough ahead and it starts training on puffer code, I'm just gonna like find and extract bits of puffer code and be like, hey, see, the coding capabilities got so much better because it finally trained on some good code. You're welcome. I think I did this right. Activations in place. Are you sure that's not for inference? I guess you could use it in the rollout collection stage. Yeah, because it'll destroy your gradients if you use it for training. Well, you're free to investigate anything, but I suggest what you do is, you make a table. In science, what you do is you make a table of things that are likely to be useful, and then you rank them from by how likely they are to be useful and how useful they're likely to be. Morning. And then you do them in approximately that order, modulo what you find interesting. To redo my web server, that's obnoxious. Hmm. So it's not happy. It should be. Oh, because I have the wrong max in there. Okay. So yeah, this is what it is with a completely screwy max. And then the max should actually here be 1. 1.0. Let's try this. Oh. Even lower. Well, we'll have to look at this. Oh wait, we don't want untransformed square wave, we want a normalized square wave. Yeah, we don't want to undo the transform. The whole point is to have the transform. Okay, so this thing doesn't work either right here. Now what about this? Invalid value. Eh? That's a little better. It's breaking because the predicted score is yeah, it's breaking with the predicted score. Plus are a little better. little better than before. Raw scores come in. You get the transform scores. 1 and 5 is probably good. And the suggestions come in. Okay, so this is a little better. You see we actually have some points out here. We don't go out to here though. Reason being the predictions are all 1. Predictions should not all be 1. These should be very nicely separated in latent space. Let me see if I'm doing it wrong. And we want to log untransformed score in, right? The heck? It's weird. Unnormalized. Let's put a breakpoint like here. Let me double check some messages. Oops. I love when Ubuntu can't update itself normally. Not that bad to update, at least. So I'm good. I don't have anything for a few hours. Puffer. Okay, normalize score mean. Got mean. So it's Gaussian. Carbs today? Work today, various work. I'm basically just stealing time to work on this whenever I can, because I have a million other projects that need to get done, but this one is very, very important to RL progress. So whenever I can, I work on this. And I have some robotic stuff that has to get done. I got some other client stuff that's got to get done today. But, you know, whenever I can do this, I do this. This is like the thing that in my mind at the moment, this needs to happen so RL moves forward. If this does not happen, RL does not move forward, period. It's that simple. I think in those sorts of terms, you know? All right, so something screwy here because what do we do? Transform scores. Did I undo it wrong? Hang on. I think I undid it wrong. You take unnormalized, wait, this is the transform, right? So negative log. So you do negative x, right? And then this gives you 1 minus this. Oh, so yeah, I'm just trolling. My bad. And then what you have to do is you do this minus, was it? Minus 1 plus x. And then you multiply max score. I don't know why it is that the autocomplete just breaks sometimes. Like, it should be completing this, right? And it's just not. It's like, come on, I'm paying for autocomplete. You're gonna make me type this. Does it just stop? Yeah. Let me do this before I at them on Twitter. Already up to date? Well, there, now it works. Yeah, you see how fast it's supposed to be? It's like instant when it works. Oh wait, this is supposed to be in transform space, isn't it? No. Something's screwy here. Let me see. Normalized force. Da, 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 da. There we go. And you actually got to do mean. We're going to start cleaning this up at some point very soon here, so I stop making these dumb mistakes. There we go. That looks way better. And I think I missed a negative sign here. How did I miss a negative sign? Is PufferLib easy to set up in Mac? It should be, and if it isn't, I'm right here. I stream almost all day, so if it isn't, you come tell me, and I fix it. You can't use Puffer Tank is the only thing. So you can't use our container because it's a GPU container. But you can absolutely just install PufferLib. I should make a CPU container at some point. That would be good. Hang on. Oh, yeah, there's a negative sign at the end. Right there. I missed a negative. Will I be able? Yes, you will be able to develop some of your own M's. The one thing that I will tell you is that if you want to write C environments, Mac as a development environment, at least as far as I have seen out of the box, you're missing some very useful debugging flags on the compiler. Um, the address sanitizer specifically, yeah, that doesn't work out of the box just on Mac in general, I think. It might be worth getting like a CPU container for that, or like just SSHing to any Linux box. But I mean, you can get by. It's just, yeah. Oh, they work with Clang 18? Perfect. Then just use Clang 18 and ignore me. Good job. See? That's why I stream. And get people answering stuff for me. It's great. Should add that to the docs. Leak detection doesn't work. That's not the most critical one. That should work though, but that's easy for me to fix in a PR. The frickin' array bounds are the annoying ones. This is beautiful. Now let's see if it actually trains. 999, yep. And I forgot the max somewhere. And how do I do this? Negative max score times numpy.x negative. Fix our map. Nan. How'd this happen? Normalized nearest Paretos. Wait, unnormalized. This times this plus this, right? MPS is a device. Start setting up. Come up if I can. If it works in Torch, it should work in Puffer as a device. Like, we're not doing anything fancy like on top of Torch. If it doesn't, you come back. And if I'm not streaming, I'm usually just taking a break to go exercise or get food. I'm pretty much always streaming my dev. Why is this then breaking? Puffer is insane. We got 120x speed up. That's on the low end. If if you run a perf test, let me know the n steps per second. Should be over 1 million. That's on one CPU core. It'll multi-process as well. Having some issues with logging of rewards. Are you free to help with this? Yes, and in fact, I have code that you can just copy paste directly in that will log everything the exact way that you should be logging it. It is in every single environment. I will give you the latest version that I stuck into the last environment that I wrote. PufferLib grid.h. All right, you see all this log code right here? There's like, I don't know, 50 lines of log code. Just use this. Copy paste in. And then you, if you look in the Python, you'll see how you aggregate logs across all your different environments. And if that's not clear enough, then yes, I can look at code directly. Also, let's see, did we get anything from, I want to see if I got any. Oh, yeah. Look at this. Did anybody actually go star it? Why is this thing not load? I think we got a few. Every so often, you got to do the star promo. Invalid in log. Ah. So how's there an invalid in log here? I think. Oh wait, log of 0 is 1. Then what was I afraid of here? Is this plus eps? I think it is plus eps, isn't it? So that's got to be minus epsilon. Solid. These look way better. $998, score $998. It's overconfident in a couple places. Why does it let the predicted score get up that high? Ideally, it should get clipped. But I think this is way better already. Let's see. Hey, look at that. So we've got 60, 30s. Still doesn't go that far out. Look at this curve, though. Look how nicely it filled this in. Holy, look at this. Where's this? Look at this right here. You see this perfect fill? That's a perfect Pareto front right there. Setup docs, puffer.ai. All our stuff. Single page, super easy. Yeah, this synthetic test, man. But we're looking at different common data distributions and making sure that it can actually work. Because here's the thing. Base carbs horribly fails the synthetic test, as do most other algorithms. So if it can't frickin' figure it out in the case where it has perfect data and a very good model, then what's it gonna do? I'd like to rescale the percentile test just a little bit here. Needs to be just a little shallower. Plus. Wait, score. 1 plus. How's this work? How the heck does this percentile test work? Am I dumb? Okay, so this is 0 to 1. Oh, I see. Let me see how this looks. It's just there are some optimal hyperparams. They're not randomized, and I'm fitting it to a curve. So I have like there's like a linear one, a log one, and a percentile one. This is strictly to test out the interaction of various terms in the objective function. There we go. That's way more reasonable. And then what's happening here is it's not getting perfect, even at high cost, because the model is... Oh no, this one's decent. Hold on. Cost 30? Yeah, okay, look at that. There, we're good. Okay, so I rescaled it just so it wouldn't all bunch up here so much. It's still a good test, right? I might have gone a little too heavy on it. We'll do cost over 10 instead. Because I want to see that it can like fill in this steep region here. So, I mean, but this is still pretty good here. Like, here's all the random data, and you see that it filled in mostly what we would want. So it filled in right here, and it filled in even over here, these points. I especially like how it's got like this dense coverage of the elbow here. And there are a couple points like down here and stuff as well, so like it is actually going to cover the lower regions. But yeah, this is good. And if we make the task a little more aggressively cut off, actually works better. I guess it makes sense. They just didn't have support before, and here I see that there are a couple higher samples. Okay. Let's see, so we did this, and now we do, whoops. We do this. Oh yeah. Look at that. Check the logging against Pong. Would you mind taking a look? Yep. Let me know what is wrong with it, and I assume the changes are pushed to the same place as before. And go find it. Looking where to go. It was in Gen Chat. Logging. Perfect. Yeah, you just paste the logging in. Going. Reset. Step. Looks fine so far. Is it not working for you? You got log buffer added in. Here's your log buffer. Right there. Yeah, so I mean that all looks fine. Is something not working? There we go. Score and reward are always the same, and the values keep disappearing. Well, that's log frequency. Values disappearing is just they're not getting logged frequently enough, most likely. But which would be very weird with a report interval of 1. But if you have a very small batch size, that's still possible. And like you have config any. No, you have a reasonable batch size. I don't know where you got these parameters from. These are moderately unhinged parameters. The 4D96 mini batch is tiny compared to the batch size in particular. Let me see, scienv. Have you rendered it? Is there a render? Oh, you guys didn't add a renderer. You should add a renderer. It won't be very much code. Because usually my debugging routine for this stuff is like, there's a C build where you just build it in C, right? So it's a standalone. And then I just will watch what the agent is doing, and I'll print out the rewards it's doing stuff and see if it's correct. So I would add like a little renderer. It's just like a point in 3D space, right? Numems and .ini. That's probably confusing, huh? All right, because you're using the ocean, you're using ocean, you have a native environment. This is when you make your environment class, right? Your like drone env, internally it's going to have 1,024 different environments. Regardless of whether you're using ocean or you're using like Atari that doesn't have the ability to do this, the number of environments here is the number of these whole things that it's going to spawn. So if you set this to 2, now you have 2048 environments. And the cool thing is technically, like, let's say that your env is fast, but not quite fast enough. You can set this to 2, you can keep this at 1, and then it's asynchronous. So it actually will trade off between blocks of 1,024 environments. But I'd add a basic little renderer. Is Spencer around? Let me link you his thing. Because he has some example code. Let me find an older version before he made all these changes for you. Okay. Here is your link. It's in the Discord. That gives you a very, very basic example on 3D rendering. You literally just need like an empty scene with, you know, a sphere for your drone, and if there are objectives or places that it's going to go to, put a sphere over there as well, and you'll be able to see what's going on. There you go. So this thing here, speeding up the ball. That would be an environment config. That would change the way the game plays. Okay, 171. So this point, yeah, right here, this is the best point. And this gets high rating. It's over predicting a little bit. Should cap it at least. Does that even help? Maybe helps a little bit. I guess it is factored into epsilon, with the epsilon. Transformers are pretty good. Transforms are pretty good. I mean, there's still a lot to do here. Try this on log real quick. Not 200, right? Hang on. Log 10. .3. It does somewhat bother me that it's chosen not to fill out this area, but the thing is, I think that this is so densely filled from the initial point estimates that this should be fine. And I saw it fill this point in, this portion in before. So I think it's probably fine. And actually, these points here are from, I think these points here are from the algorithm, right? Yeah, these points here as well. So it is doing it. Okay, so this is very good. There's even one over here. Nance. Oh, I think you have to overestimate, not underestimate. That's why. If you're gonna estimate. Try that again. The next thing, Captain, on this is going to be to figure out why the variance of the predictions is significantly overestimating the confidence of these models. Like, these models are way too confident even when they're very wrong. And then incorporating conservative bounds. Because basically I have it here, this just works when there's no noise, and you have a good Gaussian process model of Clausen's 4, or at least a pretty good one. So we have to figure out why why these are so overly confident. Hey, that's pretty nice. Introduce some noise. But the thing is, it's wrong. So, yeah. This is pretty good, though. Look at this. This is solid. Let's see if linear screws it up now because of the transform that we applied. I think this is a good transform. I think we finally found the good transform. Okay, this is suspicious. I think we broke linear. Hang on. I think we broke the easy test by solving the hard test. Don't you love it when you do that? Now you have the harder one. Yeah, friggin' thing. Well, it's not terrible, to be honest. To actually come to think of it, this is not a bad outcome because... Hold on, maybe this is a feature, not a bug. Alright, maybe this is a feature, not a bug. Can we sell this as a feature? I think we can sell this as a feature. So hear me out. Alright? You almost never see this curve in reinforcement learning, like ever. The only time you see this curve is basically when you learn a perfect policy or whatever, and you just have to run it for longer in order to get the higher and higher score. And maybe you make very small refinements along the way. I've only ever seen this in Enduro. Now, if that is the case, then there's absolutely no reason to explore the lower cost hyperparam space here as much. In fact, the only reason to explore it is if your model is not confident in its predictions. So you use it to bootstrap the confidence up. So, and then in reality here, this cost, this score, what would this be? How would you set a max score on something like that? We're probably going to have to come up with something where, if you don't give it a max score, we come up with one. Maybe it's double your current max. I mean, this isn't even bad. You fill out some points, it misses a couple, but this is a model quality problem, so we'll handle that separately. It's generally pretty good. Did it have any really bad misses here? 140 at 125. Wait, how to do that? That shouldn't be possible, right? We log in. Untransformed. Oh, no, we're good, That's possible. Yeah, because look, the prediction is just wrong by a bit. See? It's cost 120 and we only get 119. So it's fine. This is actually even a good point. This doesn't miss too bad. So none of these are really bad misses. Some of them off by a bit, but none of them are really bad misses. It's about this distance is fine. All right. Nearby distant rating mean. So rating is the overall score, where highest rating is the one that gets picked to be sampled. And the nearby distance, we're evaluating distance to nearest Pareto point and using that as part of our search criteria. I am happy with this. So we have fixed output scaling. Now I think we just look at model variance. Model variance will be the next topic. But I'm gonna go get breakfast. Go for a run, do some stuff. Got a meeting, and then I will be back in a bit.